Hey guys, Mr. Bowman here. Today's learning objective is in pink and we are learning to identify the angle properties of regular polygons. And just to recap, in the last video we looked at what a regular polygon was, and that was a shape with equal sides. So all of those sides are equal. And an example that we've looked at in a previous video, we've already looked at an equilateral triangle. So that's an example where all the sides of that shape are equal. You could also have a think about a square. And you could even get into the regular polygons like a hexagon that I've drawn there. And you can even have shapes with 8 sides, 10 sides, 12 sides, maybe even 1,000 sides. As long as the sides are all equal, it will be a regular polygon. And I'm going to change pen colors for this because this is the most really important part. So we learned when we did an isosceles triangle that all of those internal angles were the same. And that's the same with all regular polygons. If all the sides are equal, or Mr. E in shape, all internal angles will be equal. And that's the really important feature of regular polygons that we can use to solve problems with geometry and regular polygons. So let's get into a few examples. Let's explore these concepts a little bit more, and then we'll get into them. So we are going to need to memorize our formula from last time. So we learned that the total internal angles was equal to 180 times the number of sides minus 2. So that was the total internal angles. So we're going to use a square, perhaps. So that square has 4 sides. And we know all of those angles are going to be equal to each other. So let's find out, well, what do all the total internal angles add up to? So that's going to be 180, 4 minus 2 is equal to 360. So what we know from that is 4x, x being the internal angle, or all 4 of them, we know that must be equal to 360 degrees, which means x must be equal to 90 degrees. So the internal angles must all be 90 degrees in that square. And we've used 2 geometric reasonings to do that. So we know that the internal angles of 4-sided shapes sum to 360 degrees. And we've also used the idea that the internal angles of a regular polygon are all equal to each other. So internal angles of a regular polygon are equal. So we've actually used 2 geometric features to figure out that. So we're now going to get into a slightly harder question, so hopefully we're getting the hang of it. Let's say we're dealing with a hexagon. So I've got a hexagon, looks like that. That wasn't a well-drawn one. And within that hexagon, so we use the green pen, I've actually got a square in here. And the square, well, all of those sides are equal to that. And the hexagon, well, all of those sides are equal to each other as well. We can actually use all that information without being given anything. We could probably find out what angle x is. So what's that angle between the square and the hexagon? So the first step, we already know that the square all has right angles. And that was the information from our earlier example. So we know all of those. If we figure out, well, what's all of the internal angles of the hexagon going to be? I'll change pen colors for this actually so we can highlight it. We should be able to figure out the blue angle. And if we do the blue angle minus the 90 degrees, which was from the square right angle, that will reveal and tell us how much x is. So let's get into that. So the first step is, well, what's y going to be? What are the internal angles of this hexagon going to be? Well, we know the hexagon has 6 sides, and we know the formula will be 180, 6 minus 2, well, that's going to give us 720 degrees. We know the hexagon has 6 equal sides, and we've notated them as y. So we know that 6y must be equal to 720 degrees. So y must be equal to 720 divided by 6, which means y is going to be equal to 120 degrees. So I'm going to draw another example just to clarify. So that's the base of the isosceles triangle, and that's the other side, and we've got a square here. So we figured out, well, this entire angle is 120, and we know that angle is a right angle with 90 degrees. So back to green. So that means the missing portion here must be the difference between those. So 90 degrees plus that missing portion. So we're going to notate that missing portion Z now. So we know that 90 degrees plus Z, they must combine to get to 120 degrees. So that means Z, or the angle between the square and the side of the hexagon, that must be 30 degrees. And like we did for the previous example, we do need to include our geometric reasoning, but I'm not going to write them out fully again. But the first working that we did in blue, well, that was related to our reasoning up here. So we know 6-sided shapes. Well, we've figured out they must add up to what, 720 degrees. And the last feature that we used, carrying on from that, so 720 came from there. And the last feature we used is we also know that regular polygons have equal angles. Have equal, and I'm going to be a bit lazy, equal angles. So hopefully you found this video on regular polygons useful. There's one last feature about regular polygons that we're going to talk about, and that's the idea of an external angle. And we're going to use our space left over in the middle just to finish off this discussion. So external angles. So external angles, so let's use our equilateral triangle. So that's our triangle, and it's an equilateral. If we extend this side over, an external angle is the angle that sits between the extended line and the existing shape. And we already know an angle rule about lines. So we know the two angles on the line. So this angle here, which was 60 degrees, and this angle here, which is x, those two must combine to get 180 degrees. So x, also 60 plus x must be 180, which means x must be 120. So that's one way to figure out the external angle rules. I'm just going to show us another way. So we can also get to that number. So 360 divided by the number of sides will always give us the external angles. So in our case, 360, well, we have 3 sides. Well, that's also going to get us to 180 degree as well. So you can use either rule. So you can use the straight line rule, or you could use 360 degrees divided by n to find those external angles. But the external angles are typically a bit easier to figure out than the internal angles, because you do need the internal angle to do that. So that wraps up our video, guys. Hopefully you found it useful. Hopefully you understand the angle properties of regular polygons. So don't forget, we really focused on triangles, squares, and hexagons in this video, but the discussion that we've had, that applies to any shape with a regular polygon. Doesn't matter how many sides. It could have 5 sides, 7 sides, 8 sides, it could have 10,000 sides. All of those angle properties will still apply to them. So hopefully you found the video useful. Let's get into heaps of practice.